Hi, my name is Dan, and this video is one in a large set of videos which are charting the progress of going from basic electronic logic gates to creating a 4-bit CPU. I say large, I think there's going to be 55 in total in this sequence, which has then been broken down into smaller sequences. Um, there is a roadmap of where we're going in the description down below the video. There is also a link to the software that we're using to simulate. Did I say simulated? It's a simulated 4-bit CPU using a thing called DigitalWorks. There's a link down below, but we're not going to be showing it in this particular video. Within the larger scheme of videos, this is a playlist of videos which are talking about the design of the 4-bit CPU. We've done a lot of background in terms of generic electronics. We've done some stuff with the logic gates. We've created some generic parts, some more specific parts, and in this set, we're kind of finalizing the design of the CPU before we actually put everything together. Design before build can be a good thing to do at times, so let's model that behavior. In the previous videos in this sequence, in this shorter sequence, we've talked about the opcodes, we've talked about how we're going to deal with the architecture, we've talked about the fetch execute cycle, we've talked about what bits of hardware we're going to have, and finally I'm going to use a diagram to show how all these bits are going to fit together. And I hope I've remembered to put all the pieces in that I should do. So here we go. We're going to start with the buses. So buses are effectively sets of wires which allow the transfer for information. We're going to have two. We're going to have a main bus, which is over on the left-hand side, and we're going to have a special bus just for operations for our opcodes, which is part of the special architecture that I've developed for this. We're going to have a memory adjust register. So registers are connected to the bus, and where things are connected with bus-like access, I've got a blue arrow involved, and where it's hardwired, I've got black wires involved, or black arrows. So the memory address register is connected to the two memory banks that we've got, and we've got one memory bank which is going to hold data, and one that's going to be specifically for holding operations of the opcodes. And the data memory, it's got a built-in I/O register which is connected to the main bus, and the op memory has a similar built-in I/O register which is connected just to the op bus, because this is how we're going to manage to deal with fetching both of these things at once. And then once they have been got, the relative bits of data can go into either the data register, which is a register on the main bus, or the op register, which is a very specific register and is connected just to the op bus. Okay. We're going to need another couple of registers which are called A and B, which we're going to use connected to the ALU, which is the mathematical heart of the CPU. And speaking of which, let's stick that in. So those A and B are hardwired into the ALU, and the output from the ALU is part of the ALU, is the ALUX register. There's also a flags register which is not connected out to anything yet. Then there's the control unit, which is, I cannot show all the connections that it's got because it will just become a massive spider web. But it is basically connected to all of the other registers or anything else that has a built-in bus-ready register in order to say either output enable or read from the bus. So bus read and output enable and all sorts of other things are coming out of the control unit. But very specifically, we also get the op coming out of the control bus, or we could wire it directly out of the op register. I haven't made a choice on that yet. And the flags that come out from the ALU are going to affect whether how the program counter works. So they're fed back to the control unit. Talking of the program counter, we need to stick that in. So that's a very special register that's actually got two registers and some separate functionality to do with incrementing and counting. So and that's going to be connected. And then finally, the thing that creates the whole sequence of stuff, which is the ring sequencer, is going to be connected to both the control unit and to the program counter. And if you watch the video that was about that, there's going to be 4 lines to the control unit, which are fetch1, fetch2, x1 and x2. And then connected to the PC, there'll be ink1 and ink2. And the ring sequencer is then connected to the clock. And there may be some other controls as well that we're going to connect, but this is the basic architecture of our CPU. I hope that because you've watched all the other videos and taken everything in, that this diagram now makes complete sense to you, and that you kind of getting hold of where we're going with this CPU. In the next set of videos, we're actually going to start breaking apart the control unit and building that, and that's going to be the most complex bit of this whole simulation. But that's it from me for now.